Hello, welcome back. I am going to be doing connective structure today on the binary comparison. So this is going to be all the stuff that goes into the. Sorry, I'm just getting the chat, the YouTube chat. I have the YouTube chat on. But yes, today I'm going to be working on essentially the equivalent of all of this infrastructure. So this stuff here. Maybe I'll get onto that as well, but probably won't get there today. Why is it loading those chunks? Maybe it's just generic because it's the 00 address, to be fair. So anyway, first things I need wool. This is going to be a wool block episode. Lime and red. Yes, and so it needs to be something like 6 or 7 blocks out. So to be honest, this is going to be a pretty low energy episode. The last stream I did was much more interesting. So if you're on YouTube, I'd suggest you watch that instead of this one. Although obviously I suggest you also watch this one because self-interest and all that. It's interesting. Any stream all streams where I've done interesting stuff seem to get like much less views than the ones where I've done like just pretty boring things. So my light setup is kind of blinding me. Yeah, so well, that's another thing actually. I need to remember to turn my volume up slightly. Hang on. So my mic volume is actually at maximum, at least on the OBS end. So yes. Just I noticed when I was checking the streams back for quality. Firstly, there was a significant absence of quality, but also the audio was pretty quiet. So I apologise for that. I also noticed that Kick seems to be chewing up the streams, and there seems to be a connection issue there. So if you're watching over there, I'm sorry. No idea how to fix that, but it's been there seems to be I guess, a weak connection of some kind in terms of the internet. But I'm using Restream, and that should be something on their end, not my end, which is why it's odd. If you're wondering why I'm multi-streaming to Kick and YouTube rather than Twitch and YouTube, it's because I can't handle the I can't handle the Twitch lifestyle. Too many people on Twitch. Also, let's be honest, it's in everybody's best interest to support a diversity of platforms. Right, so I need to fit the memory unit in there. Remember correctly, I copy paste this thing from here down to here. When I'm doing it, I should be standing here. Ugh. Tell I'm low energy. So it needs to be beyond that. Oh, that's fine. That works. Right, so that's fine like that. I just need to bring this around here, build a switch. Not a Nintendo Switch, just a regular Switch. That was incredibly low energy for an attempt at a joke. I suppose it wasn't even really an attempt at a joke, was it? It was just like a... I don't know. This is a low energy episode, this is. Now, if you're thinking about putting insta wires here, right, it actually doesn't matter. This is something I considered on the binary adder. Having insta wires here doesn't help at all because it's the hard limit is the speed of that memory. So it's no point. Also, there's actually some, thinking about it even more, there's actually some leeway built in from the CPU anyway, because it takes a couple of seconds to load something from memory, and if it takes a couple of seconds to run the operator, right, it can start loading the next instruction from memory whilst the current operator is propagating, which will actually make it a little bit faster. Essentially, it can do more than one thing at the same time. It can make memory calls to load the next instruction whilst the current instruction is still being processed. Is what I'm saying. Here's a question. How concerned should you be when clearway traffic cones start popping up near your parked car? Like, my car's parked in a row of cars and there's a clearway traffic cone. Well, there's actually a whole bunch of them, right? But they start like one car away from where my car is, right? It's like, is my car just with? Are they about to do works there? And is my car just within the just within the bounds of the edge of it, or is it just outside the bounds of the edge of it? Because essentially, there's one traffic cone per car for about several dozen yards, and then my car is like essentially the first car without a traffic cone. It's like, am I just on the inside edge of that, or just on the outside edge of that? And also, is the local is it work that needs to be done, or is the local council going to do something silly? Right. Right. So I need to do the old signal thing. Before I put in switches, I need to do this. Right. So I need to connect these. Excuse me, sorry, just lost in thought there. So I realised having the video camera was a bit pointless because my head, I hardly ever move it. It's like I could just duct tape a photograph to my camera instead. Fill this in now. Oh, well, that's unfortunate and inconvenient. I need to put another repeater in that loop, basically. Doesn't matter too much. But it would have been nice if this pathway had been just short enough to get away with one repeater. Technically, of course, I could move this repeater along here a ways, and I might do that, but that is often a pathway to breaking something. That's interesting, I didn't know the switches powered the block beneath them as well. Rather unusual. Excuse me. Right. Now, I will be ending somewhat early today. But you can watch the last one I did instead, which was Binary Comparison 3, where I demonstrated, well, I put all this together and got it working, basically. It's like the final steps on this. Demonstrated how this lot works. And I realized it didn't give a particularly good explanation of this lot. So I will probably, just before I finish today, I'll probably walk through the circuits here, explain how they work as best I can, which won't be very well, but you know, it'll be what it is. Now, because I'm not planning to have any Boolean data type, I'm planning to feed this operator straight into what are going to be the essentially the if statement operators. I mean, there won't be if statement operators; they'll be conditional go-to operators. But basically, the output of this will be fed straight into another operator, which will be over there. Well, it won't be over there; it will be over there, but they'll be adjacent when they're over there, basically. Excuse me. Because of that, I won't need any return bus. Neither will I need any return memory here. Well, I'll have a special 3-bit memory system that will store the greater than or equal to. It will store greater than or less than or equality to. But the next thing I need to do is copy and paste the memory address controller. I think I can copy from there to here. And if I copy from here, that should put it in the right place. Interesting. Guess it needs lengthening. Now, if you haven't seen my other streams, what this is, firstly, this here is a very standard unit that I use almost everywhere. This is just the address operator, so this takes as its input a 4-bit address code. Although I may at some point have to uprate this to 5 bits, which will be very easy. A 4-bit address code, and basically it just does XOR and then AND all the way down to the bottom. If it's a match, so the address gets encoded in these switches. So that's the top switch, and there's a switch in the middle, and there's a switch at the bottom, right? So there's 4 switches, and that encodes the address number. If it's a match, then basically that means this is the correct address, which turns this signal on here, which turns everything else on. Now, what this here is, this is a state operator. This is a state sensor, rather. This records the number of times that this operator has been turned on and off, which is important because this operator has 3 states. It has the state where it's ready to receive a number to this stack here, then it has a state in which it's got a number in this stack here and then needs to receive a number to this stack here, and that's the state where it then does the comparison. So that's this. So essentially, it puts number in here, waits for second number. When the second number arrives, it sends it to here, does the comparison, then saves it, and then that puts it into state 3, which is where it saves, which is where essentially it's ready to send the number to the next operator. And that's what this block here does. This block records how many times this thing has been. Well, it has a repeating cycle of 3 states that switch every time the redstone gets turned on, basically. And I spent several streams coming up with this design. It's probably not a good design, but it's at least simple and it works. And that's all I care about. Now, because I'm very busy, I'm very busy right now. I'm not gonna plug this in. I'm going to come over here and I'm going to explain this bit, and then I'm going to sign out. How long have I been live for? Aiming for at least 40 minutes. Yeah, that's fine. That's fine. I can say I've streamed. So it's got. So basically, essentially, this is just a set of switches. So this here, that's an AND gate in the middle there, and then that AND gate ties into switches on each side. So if both sides are on, that triggers the AND gate, which sends a signal to switch both sides off, basically. Which means that if the bits match, then no signal propagates further than this layer here, right? But if one side is on and the other side is off, then that... Sorry, scratching, excuse me, that's pretty rude of me. Then that sends a signal forward to propagate to this next layer here. And when it gets here, right, the first thing that has to be done is it has to... well, the first thing it has to do is it has to send the signal down the side here, and this is important because this overwrites every lower state to be on, basically, so all of these get turned on. Which means that, essentially, all of these layers will be turned on up to the highest order mismatched bit, right? So, as soon as there's a mismatch, every one of these will get turned on below it. And then that circuit is repeated here. So this here is essentially the same circuit as that. And essentially, if one side is turned on and the other side is turned off, it allows the signal to propagate on the side that's turned on. So here, this side's turned on and that side's turned off, so that propagates along here, right? But if this side is turned on as well, there is no there actually would be propagation still on this side, I think, because I think it overrides it, but that's not so important, right? The main purpose of this circuit here is to identify which side has the higher unmatched 1 in it, basically. So in this case, this side has the highest unmatched 1, and it's the top one. So this leading binary number is 1 here, so it's 0 on the other side. So that's mismatched, which means that this has a higher power mismatched 1 in it, which then turns off, which means that this number is larger, basically. So let's imagine that let's imagine there was a 1 on the other side and this side, right? That would turn all of them on down to the bottom there, and then it would turn all of these on down to the bottom, right? But because this side would also be on, right, that they would cancel out and all of these would be off down to the bottom, and then that would leave only this one at the top on, which would mean that only this side was outputting a binary on switch signal, which means that this side would be detected as larger. Although, yeah, I mean, that's essentially how it works. It's a little bit, it's not quite that, because it doesn't quite, I think it remains overridden all the way to the bottom, and so this side would never turn on if there's a lower order bit that's 1. So, but essentially that's how it works. And that's all done by this second AND gate here that's looking for unmatched bits in the stack of 1s, basically, to determine which one's higher. So first step reduce each number into a stack of ones that leads up to the highest mismatched one in each number. So if there's a 1 in one number and it's not matched in the other number, build up a stack of ones to that rank of 2 essentially, and then do the same for the other number. And then second step is to identify which number has the higher of those 2 stacks, and the way to do that is to do the same first step and identify which side has the mismatched one, which will be, potentially the highest power of 2 will be mismatched on the other side because the stack will be shorter. On the smaller side, the stack will be shorter. And just to give you a good overview of that circuit. Now these here are just here to put some delay into the system. Don't know if there was a reason why I used comparators instead of repeaters. It's an odd one. Why did I use comparators there rather than repeaters? Oh yeah, I know why I used comparators rather than repeaters. If I'd used a repeater here, that signal would not have been able to turn it off. Basically, that's why I used comparators. Yeah, because putting a repeater here meant I had to put a repeater there, which added an extra tick of delay to this, right? Which meant I had to slow this down by another tick, which meant it was a little bit slower. But I had to put this repeater here because comparators don't have variable delay, and there's not room for 3 comparators in this line. But yes. So, thank you for tuning in this evening, and that's going to be all for today. Given how busy I am right now, I probably won't stream again until Friday night.